Hey guys, Luke from O'Brien Engineering here today. We thought we'd do something a bit different. We're going to do a laser race.
Fight!
At O'Brien's we've got 3 different lasers here. We're going to peg each of our machines against each other. We're going to cut the same material and same design in each machine, so there's no added variables. It'll just come down to the piercing and the speeds at which the machine can cut. We've got 3 different materials here that we're going to trial for today. The designs I've picked today will showcase a straight edge, cutting lots of holes, more detail through the plate, and we'll see what stands up the test of time.
Fight!
Alright, as you can see here we've got the 3 versions. Here is the LCG, in the middle is our CO2, and then on the far side is our Ventus fibre cutter laser. Well, as to be expected, the clear winner was probably the Ventus. The CO2 on it was a very notable amount slower than our fibre lasers. The one advantage of the CO2, which is hard to see but hopefully we can get a close-up, is along here there is a really nice polished edge. That edge and that cut quality surpassed what the fibres could produce. These are still very acceptable cutting results, but that was a clear difference, and it's the main differential between the 2 machines. So here the first test we did for each of the machines was 3mm stainless steel. The Ventus produced the fastest cutting time, which was under 20 seconds, which is an incredible speed for something travelling 100mm on each edge plus the internal cutouts. But the one very notable difference that sets the CO2 apart from the fibre lasers is that cut edge quality. You can see along here, it's almost in comparison, almost like a polished edge versus the 2 fibre laser machines. It has a beautiful cut edge, and you can see there's less of that striation through the cut edge, which is on the side of the plate. The next shape that we cut was out of aluminium. We intentionally did something with a lot of holes and a lot of internal cutouts. They're quite small. Some of these holes are under 3mm in diameter. The cut appearance on the front face for them, for the most part, is very, very similar. The one critical difference for all of this was that Ventus did cut at such a fast speed with its fly cutting capability and still produce such a beautiful cut on the front. As far as burring goes on the back side, I'd say the LCG probably was marginally better, but the Ventus was notably quicker. It was almost probably 2 times the speed in comparison to the other fibre, and probably 4 times faster than the CO2. The 3 here that we cut out of the zinc steel, across each machine there's very little difference. Again, it came down to the timing of it all. The Ventus was the clear favourite. It was faster, it was probably half the speed of our other fibre, and probably 4 times faster than the CO2. But as far as cut quality and the burring, we ended up with the same, very, very similar results, and all very acceptable for the industry. You're probably wondering, if they're all so similar, what would be the main advantage for us having all these different machines? One, it gives us the ability to run certain machines on using certain materials, i.e. the CO2, we would not cut brass on that machine. The fibres are designed for that due to reflection issues. Brass will actually damage our CO2. But that being said, the CO2, as we saw, has an amazing cut quality, especially on the thicker grade stuff like your stainless, it almost pre-polishes the edges. And it's such a beautiful finish straight off the machine. The fibers give us obviously the brass cutting capabilities, but especially on the thinner materials and fine detail cutting, its breakneck speeds and high quality ensures that we can produce a lot of small parts very quickly. In addition to that, the machines are more efficient. They're not using as much power, they're environmentally friendly, and long term, we still get to cover all the different materials that all our customers require.